Welcome to part 4 of Competency 5. In this video, we will work with domain and range of functions. Displayed are some properties of rational and radical functions. They are not all the properties that you need to know. However, in this video, we don't focus on those properties. We use the TI-84 in a more visual way and connecting it to the notation that you will see in the questions and the related answer options for each question. Please do not think that we are downplaying the importance of all these properties. You do need to know them as an educator, and I recommend finding videos and other resources to review them. Number 1, what is the domain of the function y equals 3 over x plus 7. Okay, we're just going to graph that. Y equals arrow over alpha, y equals again. That will give us the fractional setup. And we have 3 arrow down. And we need to say x plus 7. Okay, let's look at the graph. Okay, let's zoom in just a smidge. That's a little better. Okay, and what it is we need to say is that x plus 7 cannot equal 0. Well, that gives us x. That gives us the fact that x cannot equal -7 when we solve for x. So A says all real numbers. Well, obviously there's a gap in our domain right here at -7. So, and this one says that except for x equals 7, no. And this one has x equal 3, so that doesn't even apply. C is correct. It says all real numbers, but x cannot equal -7. Well, that's what we just said. Let's verify that with the table. Second graph, and we need to go to -7. I'll just arrow up. And there's an error, which confirms what we said. It can't equal -7. It can equal everything else, but not -7. Okay, so let's go to number 2. What is the domain and range of the function y equals 2 minus x over x squared plus, -25? Okay, let's just, again, put it in the calculator. All right, and I'm just going to type over. I have 2 minus x, and then x squared minus 25. Okay, let's graph that. Okay, I know it looks a little funny, but what you need to do is push zoom 7. Let's go to the zoom. Number 7 says Z trig. This is a little different. I know that you may not recognize the form, but this is in the form of a trig function. It actually is. If you don't remember trig and it's been years, believe me. So we need to say number 7. Now we get something pretty and clean. Okay, and those properties that I talked about, they don't apply here. It's not going to work. It'll give you some of what you need, but it's not valid at this point. That's why I said I'm not going to focus on that. We're going to go with what we see. I see a domain that's all real numbers, but we have a gap at 2 places. And we can see by our denominator that x cannot equal plus or minus 5. But that's not super evident the way that it's graphed if we go to count each of these marks. That's not going to tell us what we need. That's why I don't do it very often. So you need to push second graph, and let's look right there. -5, verified. Can't equal -5. Let's go to 5 and verify. Go down. And can't equal 5. So A's out because A's saying all real numbers. Let's look at B. Okay, B is telling us that there is a gap here at -5 and 5. You may not be familiar with the notation, but it is a common notation. Let's look at C. All real numbers but 0? Nope, we include 0. D says all real numbers except 5. No, because we need -5. Well, that pretty much it does. It eliminates everything but B. Now, let's look at the range. Okay, we can go up and down. As you can see, if we're looking at the range, let's look at the graph. That actually includes everything. There isn't, it might for a second look like you're going to have a gap at y equals 0, but that's not true. The range is all real numbers. So let's take a look here back at our table. And okay, let me go back to the graph so I can just eyeball it. 0 was around, I'd say, this I think is going by 2s. It's not going, the axis isn't counting by 1s, obviously. So let's go here because we changed it to trig. Let's go back to around to that 2-ish. Yeah, there it is. 2. Right here. Okay, so that verifies that 0 is also included. Everything is included as far as the range. Okay, let's look at number 3. What is the domain of the function y equals 6x over 2x squared plus 7x minus 4? Again, let's just graph that. Okay, push y equals, and let's type over 6x, okay, and we can push delete, go down, and, let's just, let me just clear it all out. Sometimes it's better to clear the whole thing out. Remember, we did alpha y equals, now it highlights what we want because it's too easy to make a mistake, and let's just not do that. Okay, so then we have 2x squared plus 7x, and then minus that 4. All right, let's push that graph. Okay. Oh, that's a little different. I'm seeing maybe at a half, and then if it's counting by 1s, 2 around, no, it's not. It's counting by 2s. Yep, it is. 2, 4. Let's get a different graph. Let's see if 6 is better. Now it's counting by 1s. Okay, I agree. I have a half, about, and 1, 2, 3, 4, and about 4. So let's look at our table, second graph, and 4. Oh, we're going to have to say second window, and this needs to go up by halves. That's the glitch. Okay, now second graph. Okay, so we have an error at a half, and then we have an error. We need to go to the negatives. We have an error at 4. And everything else looked acceptable. Yes. So all real numbers for A? No. B, a half and -4, I agree with. However, C had backwards signs. This one had negative, that one had positive, so no. And then D had both positive, and that isn't acceptable. Okay, so B is our option. What is the domain of the function y equals under the radical 3x plus 15? Let's graph that, okay? And I'll arrow over. Now it's where I need, the cursor's where I need it. And we say second x squared. And you see that blue radical above the x squared. Oops, I pushed it. Let me delete that. See how I can delete it out and it goes, now I'm where I want to be. Ooh, be careful what you push, right? Okay, 3x plus 15. Okay, now we see from our graph that our domain, we're going to go along the x-axis. Looks like -5 right there, and then everything above, okay? So let's get rid of the 5s. A doesn't work, B doesn't work. Now, does it include at -5? Where x is -5, is there a y value? That's the question we need to answer. So now we go second graph, and right here at -5, there is a value of 0. So C is our option. Okay? Now let's look at number 5. What is the domain of the function y equals radical under the radical 20 minus 6x? Okay, let's go back and pop over. We're just going to type it in. 20 minus 6x. Graph it. Now we need x values that are all less than this right here. So we need to figure out what that is. It's not right on 3. Well, if we pull out here, sorry about that. If we pull out 20 minus 6x equals that 0, and this is what we're going to have, 20 equals minus 6. Oh, sorry, not minus. Oh, that's just 6x because I moved it over. 6x, and we divide by 6. That's really what we're doing. Okay, so, but let's go to our table. Second graph, and we need to go and look at your options. They're saying go around 3 1/3. Oh, well, then we've got to say second window, and I'm going to say let's start at 3, but we need to set up our table as 1 divided by 3, 1/3. Now, I'm going to push enter because it'll change it to that repeating 3. Second graph. Oh, see how we have error, error, error? And that's where our 0 value is. So we need to include the 3 1/3. So this one doesn't include it, it's out. And we don't want negative, we want positive. So both of those are out. So the only one that works is A. And verified, yes, it is every x value less. As you see, it's going towards the negative. Let's look at our graph again. Everything less than or equal to 3 1/3. Because remember, we count the y equals 0 right there. Okay? All right, let's go to number 6. Okay, what is the domain and range of the function y equals? Oh, this one's dicey. Everything under the radical, and that's 20 minus 6x over x squared minus 1. Okay, we're just going to enter that in the y equals. We're going to clear everything out first. I'm just going to start out fresh, okay? So I'm going to say second x equals, now my radical. Then I have to go to alpha y equals. Number 1 is highlighted. That's what I want. Now I start entering. Okay, 20 minus 6x. And that is correct. And I arrow down. And then I say x squared minus 1. So go minus 1. Let's graph that. That's going to be interesting. Okay, I buy that. That looks about right. First, I can tell right off A isn't going to work. All real numbers, either way, it's just not okay. And the graph is interesting, and I'm looking right here. I'm wondering if that actually visually is correct. So I'm going to go ahead. Before I move on with my options, let's say second table. Yeah, see, we've got some interesting things going on, and we are going to need those fractions, looking at the other options. Okay, so it looks like the table at 1, there's an error. At 0, that works. Let's go back to our graph. Looks like there's a gap here. that includes the origin, the y. So it never touches the y-axis. But then right in here about 1, 2, 3, a little over +3, it just stops. So that's maybe 3 1/3 again, maybe? I'm looking at the options. Maybe something that looks like it might be 3 1/3 again. So let's go to our graph and let's go +3 1/3 includes 0, but then everything after it is an error. So it just kind of stops here. So we know, what, let's just look at our range. Our range, then it does include 0. So it's 0 up. Okay. Well, let's look at B. Does B in the range say 0 up? No. Let's look at the domain of B. All real numbers except 1. Not even close, and 1 is included, looks like. So I wouldn't believe that. Let's look at C. Okay, it says all the numbers from -infinity to -1, and there's a gap between -1 and 1. Okay, well, let's go to second graph, -1 and 1. We'll see how 1 has an error. 1 has an error, and that error goes all the way to -1. Okay, I believe that. I believe that one. And then it says, okay, we go from 1 to 3 1/3. 10/3 does equal 3 1/3, by the way. And it says we include where it kind of stops, and then we include it. That's what this bar means, okay? Instead of, let's say, a parentheses. So let's arrow down and look at that again, and past that, it verifies past 3 1/3, we have an error. It just stops. So what about our range on C? Well, that is y is greater than or equal to 0. I believe C. That looks exactly like our graph. But let's check D. Domain, all real numbers except y equals 0. That doesn't make sense. That should be x equals 0. Domain is related to y, not x. And this range doesn't make sense either. It's saying there's only answers between -1 and 1. That's not what I see. I see 0 and up. So no, that doesn't make sense. And the domain didn't make sense at all. Okay, so C is verified. Okay, that's the last question in this video. And once again, we really appreciate your likes, shares, and subscriptions. And happy testing, everybody.